So we went through this percentage. Okay, the rest is just additional information for you. It's a old information, but we already repeat all these things already. So this one you go home and read. Okay, go home and read. This is PERT presentation. So some of you might using the software. So from the software, you will see blast point and sync point. What is blast point? Blast point means it's an extension from one node to many node. Sync node is many node into one node. Okay, blast and sync. Okay, if you take electronic, it will be like the AND gate lah. It will be like the AND gate. Gantt chart, milestone chart, PERT. Okay, this one you read lah. You already know already. So we already cover this one. So only I need to highlight the word immediate predecessors. Immediate predecessors means if you read this table, B, the previous arrow is pointing from A. Like for example, B, immediate predecessor is A. Okay. So you try to build one. This one I will draw in the. Let's say I give you this table. Are you able to draw the AON network? So here, I have start. I point to A. Time is 1. So I know next one will be B. I just draw somewhere in the space here. I know it's B. Immediate predecessor is A. So arrow pointing from A to B. Remember, arrow is Morton. B, you copy 5 here. Next one, C. C, immediate predecessors is A. So again, draw C, arrow pointing from A. Time you read lah. Then D. D is B. You draw somewhere. So you move from the left to right. So you can draw somewhere lah. So usually it's parallel. D. Then B. E is from B also. So you extend. F is from C. G is from C. So you build from left to right. H is D and F. H is here. D and F. I is from H. J, E and I. K, G and J. Put an N there. Okay. So your this is how you build. Okay, roughly like that. But this is not the previous one. I just show you the example, not from the previous one. So you really learn how to do critical path, slack times. This one you need to do analysis. This is you need to do analysis. PERT. So this is differences between PERT chart and CPM chart. Okay. So as you can see from the previous test, sometimes we ask you the differences between something and something. So this is the answer if the question asks you the differences between PRT and CPM. Okay. So this one, if this question come out, you just break into two half, then you build a table, then you write what is the characteristic. This is another graphical presentation. This graphical evaluation review. This one is usually used for hand sketching when you do it, but I'm not going to ask you this one, GRT, just for info only. This one you need to read a little bit. What is the dependencies? Right? There are three: hard logic, soft logic, and beyond control. Mandatory, cannot change. For example, wall of the house before putting the roof is mandatory. You need to build the wall first before you put in the top. It's mandatory dependency. It's a simple logic. Very hard logic means it must happen. Right? So for example, when you cook, you must cut veggie first before you can cook the soup or something. Right? The process must be there. Discretionary means it depends on the choice or option of the PM. External dependent is outside the environment, outside the control of the PM. Slack time, okay. Slack time, earliest. You take the latest minus earliest. Right. This one you already learned. This one you read lah. Learn. So there are other presentation of numbers there. Some textbook, they will give you a few number there. Okay. So as you can see here, the 6 number actually is the box. It's just different presentation. Yeah. But in exam, don't write this one. Exam, you will be told a certain way of answering. Usually I use the box one. Okay, forward part, backward pass, we already learned. This is your information for your info. How to find the things. Network iteration. Okay. This one you read. Okay, this is also important. This one is on the theory part, maybe part A or part C, or somewhere in the question. You ask you, what is the network replanning techniques? There are two. You do resource leveling and allocation. Okay, leveling means you eliminate the peak of the valley. You level it. And that one is allocation. You find the possible critical path and then you delegate the resources. Basically, this one you just memorize. If this question come out. This one, the rest you read. Polarization. Okay, so this one you already know already what is pessimistic, optimistic, most likely, completion time, A, M, and B. It's repeated. This just the purpose of showing you this one is to tell you actually there are many presentation of value. One textbook will be different from other textbook, just in case you read other textbook. The concept is still there. Normal distribution. We will focus on this one in later chapter. So we break the curve into 6 sigma or 6 area. So we chop the curve. So if within 2 sigma, 2 means 2 area, 1 sigma, 2 sigma, right? So 1 sigma, 1 sigma, total 2 sigma. So if within the 2 sigma, means your data represents 68% of your pool. Okay, if it's 2 sigma. If your data is 4 sigma, 4 sigma means 2 sigma on the right, 2 sigma on the right, on the left. Total data, you're representing 95% data of your pool. So if your factory or QA system use 6 sigma approach, you are looking at 99.7% of data, 6 sigma. That's why if you go to Motorola, if you go to IBM, if you go to Intel, most of the time you will see 6 sigma practice or in the QA. You are actually analyzing 99.7% of the production products. Means one lot usually is 1 million, one lot usually in the million unit. So 1 million piece of small chips, they look at 99.7% of the data, they extract, they cannot allow 1 pieces, 99%. So they don't allow the error on the left and right. So it's about 0.3% toleration there. Just for info lah. Okay. Remember this number. 2 sigma equal 98%. 4 sigma equal to 95%. 6 sigma 99.7%. Remember these 2, 4, 6 mean how large the sample size. It is important for your next lecture material. Okay. This one already know already. By now, when you see this table, you should be able to understand how to get all these numbers. The rest you read, just for your info. The rest you read. Okay, if this one come out, I'll let you know. This one, if you have time, you go and read. First time. This is depending on the arrow. So when you draw arrow, don't use the correct one. Okay, usually we'll use finish to start presentation. Means finish. This is on the left is start, on the right is finish. So if you draw finish to start, presentation will be like this. If you start to start means the arrow will be from start to start. Start to start means if you start activity 1, activity 2 also start at the same time. Okay. So if you have finish to start means you need to wait for activity 1 to finish, then only you can start activity 2, for example. Finish to finish, this one, you are joining finish time to finish time means the 2 item here, activity 1 and 2 must finish at the same time. It doesn't matter when you start. The finish time must be same. This one, start to finish. Start to finish means the project, activity 1 and 2 must start. When activity 1 start already, activity 2 must finish. Something like this. Okay. The rest you read. Let. Okay. This one you read. Let you read. Okay. The rest, the quiz, I think you can go through. The answer is there. Okay. With this, we complete chapter 5.